here we go in the home stretch of our problems here. Continuous functions, all right? Now, I'm going to put another video out to explain where this continuous equation comes from, right? But when you're dealing with continuous, it means it's happening every second, every moment of the day. Let me think of a few examples of something that's continuous, okay? Bacteria growing on a sandwich, right? The little bacteria colonies are going to grow continuously. It's not like you're going to have one bacteria and then all of a sudden you're magically going to have 5 bacteria. No, it's going to happen every second, every moment. 1, 2, 3, 4, 5, 6, 7. It's going to continuously grow. That's what continuous means. It means that we are growing every second, every moment of the day. Maybe another example of continuous growth is human population. Every second, every moment of the day, someone is born. Our population is continuously growing, okay? So when we're dealing with continuous interest, our equation is y equals a e to the RT, where a is the starting balance, starting amount. Okay, E, this is just a number. It's 2.71. Okay, it's exponential. Again, this comes from what you do is you got, let's say, $1 invested at 100% rate, and what you do is instead of compounding it monthly, daily, you compound it 1,000 times, 5,000. You keep doing that until it gets closer and closer to being continuous, and you magically approach this 2.71, right? So that's just our base. The R represents the percent rate. We just need to just make sure this is as a decimal. And T represents time, whatever it is the problem's asking us about, whether they want to know how much is there in 3 years, 3 months, 3 seconds, etc. All right. So to start this problem off, well, it's not too bad. Our starting amount is just 400. So 400 E to the, well, it's at a 12% rate, 12%. Let's turn that to a decimal by dividing by 100. And 12 divided by 100 is 0.12. So I know I'm just going to get 0.12 times T. And that's it. I'm done setting up my equation, right? The hardest part was getting to this equation, but after you got this section here, you're done. It's all set up, okay? Okay, so let's go ahead and find out how much the investment will be in 3 years. So 0.12 times 3. Let's go ahead and solve this. We're going to have 400. Okay. You'll notice the E is located right here next to the division sign. So you hit the second and then the division sign and then the raise button. I'm going to put a set of parentheses. 0.12 times 3 times 3. Close the parentheses. And we are going to get $573. $573. Okay, and that's basically how we set problems up like this. All right, let's go ahead and let's look at another problem. Let's say we have, a tooth. Okay, now let's say a bacteria with 118 million colonies. Okay, it's growing continuously at a rate of 78%. Okay, how much does the colonies have in 5 weeks? So again, we have y is equal to a e to the RT. To find our rate, it's 78. Divide that by 100. To turn it to a decimal, we get 0.78. So that's it. All we gotta do now is just set our problem up, and we are going to be just fine. Y is equal to, I started off with 118 million e to the 0.78 times t. How much in 5 weeks? Let's plug in the 5 there. So y is equal to 118 e to the 0.78 times 5. And if we plug that into our calculator, we should be getting 118 e to the 0.78 times 5. And we shall have, well, look at that, 5,829 million colonies. Okay, so you could see after a while, especially at such a huge percent rate, this is going to increase like crazy. This is technically what's after million, billion, 5,829,000,000 colonies. And that's it. Continuous interest is not too hard to set up. The hardest part is getting to it. It's getting to how you get that model. And I'll hopefully release a video soon on how to do that. Thank you, and you have a fantastic day.